You still got to present it.
Okay, 410, quadratic functions. So we have now taken equations and graphed quadratic functions. Now we're going to take graphs and create the equation. Okay, what are the three forms that we have for quadratic functions?
Standard form.
Standard, okay. So standard form says what?
AX plus BX.
AX squared
Yes.
plus BX plus C. Okay, that's one form. That's standard. What other form do we have? We got two more. Yeah, vertex. Good job. Vertex. And what's vertex form look like?
A
And then parentheses.
X minus H
And what goes here?
squared
Squared. And then what?
plus K.
Plus K. Beautiful. Good. You guys are doing good. And then what's the third form that we have?
Intercept form.
Intercept. Okay, and what does intercept form look like? A times what?
P plus something.
Okay, yeah, okay. You're on the right track. How about x minus p and x minus q? Okay? So we have standard form, vertex form, and intercept form.
I totally forgot about it.
I know. That's what
Seems
we,
like it's been
that's literally what I just showed you in that problem we went over. I took it down to intercept form.
Oh.
Because when I factor it out, that's intercept form, okay?
Nice.
Okay. Now, here's the deal. We have to be able to look at a graph and decide what pieces of information do they give us so that we can create an equation that fits one of these three, okay? So, I'm going to tell you, I honestly think this is easier than sometimes graphing, okay? So, if I look at this blue equation here, it says write a quadratic function for the given graph. What information do they give us?
The vertex.
The vertex, and then they give us a point. So what form do you think we're going to put this in?
Vertex form.
Yes, if they give us a vertex, we put it in vertex form. Okay? And in vertex form, you told me over there what it was. You said it was a times x minus h squared plus k, correct?
Yes.
Okay, so let's start by plugging in what we know. And it should say y equals, right? Okay, so let's start with what we know. We know the vertex, so where do I plug that vertex into?
The equation.
Okay,
So
what part?
X goes with the H is a bunch.
Yes, and then k is the,
Negative 2.
so I get y equals a x minus 1 squared minus 2. Because remember, the k stays whatever it is, the h changes signs. Okay? Yeah, opposite. Good. Okay, now, they gave us this point for a reason. Where do you think I'm going to plug those numbers into?
You plug the 2 for the Y.
Yeah, and I'm going to plug the 3 in for the,
A.
no,
X.
x.
Oh, X.
Because we have to find the a.
Oh, you have to find it.
Okay, because we don't know the a, but we do have a point which is xy. Okay, so now I'm going to say 2 equals a 3 minus 1 squared minus 2. And now I'm going to go ahead and do all the work behind this to solve for a. So 2 equals a. What's 3 minus 1?
2.
And then I have that squared minus 2. Okay? What's 2 squared?
4.
So I get 4a, yes?
Yes.
Minus 2. Now what do I do from there to solve? What do you have to do with this?
Add 2.
Yeah, add 2 to both sides. And you get 4 equals 4a, so then a equals what? 1. So then when I write my equation, I literally go back to what I started with right here, and I plug 1 in for a. So you say,
Could you just leave it as A?
no, you would just take the a away.
Oh, okay.
So in your book, they're going to give you the answer that looks like this. If it is a 1, I don't have to put anything where the a is. If it's any other number, I've got to put it in front of it. Okay.
Can you put it on?
You can put a 1 there, yeah.
Yeah.
It's not wrong if you put a 1 there. I'm just telling you in your book, they're not going to put the 1 there, so don't get confused when you're checking your answers. Same thing, okay? Okay, do you think, I feel like that's pretty straightforward and easy. I plug the vertex in, I plug the point in, I solve for a, and then I rewrite my equation. Okay? You can totally handle doing that. Now, look at this red one. They want us to write a quadratic function for the given graph. What pieces of information do they give us here?
Points.
They give us, what do you mean by points?
They give us.
They give us one random point, which is 3, 2, right?
Yes.
What are those other points, the -1 and the 4? What are they on?
Intercepts.
They're on the intercepts. They're my x-intercepts. So what form is this going to be in?
Intercept.
Intercept form. Okay? You have to be able to recognize that. And intercept form says y equals a, x minus p, x minus q. So what do you think we're going to do with this equation?
Put the x in the equation.
Okay, remember, okay, sort of, okay. I know that those are your x-intercepts, but they don't replace the x, they replace what? The p and q. The x will get replaced by this random point here, so that I can plug it into the x and y, okay? So we're going to replace the p and q. So my first one should say x, and this is what? -1, so it becomes what here? Positive 1, okay? And this is 4, so it becomes -4. Okay. Now I've replaced those. Can you handle?
P and Q are the opposite.
P and Q are also the opposite. Anytime it's in parentheses, it's the opposite. It's the easy way to remember it. Okay, on vertex form, if it's in the parentheses, it's the opposite. On intercept form, if it's in the parentheses, it's the opposite. Okay, now what do we have to do from there? Plug in 3, 2. So 2 goes where y is. I have a, and I have 3 plus 1, and I have 3 minus 4. Okay. What is 3 plus 1?
4.
And what is 3 minus 4? And when I multiply all this together, I get 2 equals -4a, right? Now what do I do?
Divide by -4.
Divide by -4, beautiful.
That's correct.
And a equals what?
-1/2.
Good, that's perfectly fine. Now, I literally am taking this equation right here and just putting a into it. Okay? So, y equals -1/2 x plus 1 x minus 4.
That's the answer.
That's your answer. So I'm taking whatever a is and I'm plugging it back in right there to that equation I originally set up. Okay? Now look, pay attention to this. On quadratic vertex form, they give you a vertex and 1 point. They only give you 2 things. On intercept form, they give you 3 things. They have to give you 2 intercepts and then they give you another random point. Okay? Vertex is easy because it's just a vertex and a random point. On intercept, it's 2 intercepts and a random point. Okay? Now, when you are doing standard form, they're going to give you 3 random points. Whether it's on a graph or whether it's written in like a paragraph form, it's just 3 random points. Okay? This is the one that takes longer to do. So if you're writing a quadratic function in standard form for a parabola that passes through the points -1, -3, 0, -4, and 2, 6. Standard form says y equals ax squared plus bx plus c, correct? Okay. Okay, so my standard form, standard says y equals ax squared plus bx plus c. Okay. This is where that substitution thing / elimination thing we learned before comes into play. Okay, this is going to be the one that's harder than others. You're going to create 3 different equations. Okay, 1 for each point. Okay, this is an x, this is a y. So I plug this into every x spot, I plug this into every y spot. So I'm going to start with 3 different equations. So step 1 is write 3 equations. Okay, and I'm going to say -3 equals a times -1 squared plus b times -1 plus c. Then I'm going to say -4 equals a times 0 squared plus b times 0 plus c. Then I'm going to say 6 equals a times 2 squared plus b times 2 plus c. Okay, I have 3 equations. Step 2 is to simplify. The 3 equations. Okay, so we're going to simplify all of these. I'm going to do them like this so that we can see them simplified. -3 equals, what's -1 squared?
1.
So 1 times a is just a. Okay, we're just going to put it as a. And then I have b times -1, which gives me -b, and then I just have plus c. Okay. On this one, I have -4 equals, well, I have 0 times a and 0 times b, so I get 0, and I'm left with,
Plus c.
so just c is fine. Okay, which is beautiful because now look, I have something to substitute in. Okay, bless you. Now I have 6 equals, what's 2 squared?
4.
So I have 4a, then I have 2b, and then I have c. Correct? Okay. Now, I could substitute this in, but I really don't need to right now because I can do elimination with these two to get rid of the c's. Do you get what I'm saying? Okay. And then I can just be left with A and B, and then I can do some more elimination and fun stuff like that. Okay, so I get C is -4. So let's now, step 3 is elimination or substitution, whatever you have to do. Okay. Like I said, all of this stuff is stuff we've learned already, right? We just got to remember. So I'm going to focus on this equation right here and this equation right here. Okay? We know we can eliminate the C's. Yeah?
Yes.
Okay? And if I eliminate the C's, actually, let's go ahead and do substitution. Let's substitute 4 into the C for all of this. Okay? We're going to do substitution this time. So that I have -3 equals A minus B minus 4. Now, let's get this equation so that this -4 gets over here. Add 4. And I get 1 equals A minus B. I'm going to do the same thing here. 6 equals 4A plus 2B minus 4. And I'm going to add 4, correct?
Yes.
Okay. And then I get 10, right? 10 equals 4A plus 2B.
This is where you do elimination.
Now I'm going to do elimination. Okay? So step 3 is a combination of substitution and elimination. Okay? Now, this, what do you want to get rid of? The A or the B? It doesn't matter.
Get rid of the
What sign is
or
this?
B.
It's a negative already, and this is A.
Oh,
So it makes it easier if I just take this and multiply by what?
negative.
Not negative.
Oh.
Well, yeah, but what number am I going to multiply
Oh.
by? 2. So let's just take this equation and multiply by 2, right? And then you get 2 equals 2A minus 2B. And I've set myself up for simple elimination there. What's 10 plus 2?
12.
And then I get 4 plus 2. And I divide by 6, and A is 2. Now I have an A, and I have a C. So then I can take A and C and plug it back into one of these original equations. I'm going to pick this one because it's simple. Okay? So then step 4 is plug in the 2 variables you found. I'm going to say negative 3 equals 2 minus b minus 4. So I get negative 3 equals negative b minus 2. I add 2 to both sides. Negative 1 equals negative b. Divide by negative 1, and b equals 1. Now look, A, B, C. Okay? Now, step 5 is write your equation. And I have y equals, my A is, so 2x squared. My B is, so just x. That's how they're going to write it in your book. You can put a 1 there. And then my C is negative 4.
A lot of work.
It is a lot of work. The first two are very simple, if you ask me. This one takes a lot more time. Okay?
So after we get done with chapter 10, it would be a test or just a quiz?
Yeah, we're going to test over section 6 through 10.
Oh.
That's nice.
Okay. So that is what you are looking at, okay? You know vertex form, you know intercept form, and you know standard form. You told me that already. You did a great job telling me that. When there's a graph and they give you a vertex, or when there's not a graph and they give you a vertex and a point, you're putting it in vertex form. You're putting it in that form, and then you're solving for A, and then you're putting that back in, the equation's done. When you are looking for intercept form, they have to give you 2 x-intercepts, which means if it's not on a graph, it would say 1, 0, and 6, 0, or something like that. The y's would always have zeros. That's how I know they're intercepts. And it gives you 1 random point. You go through that, you solve for A again, you plug it back in, you've got your equation. Standard form takes time. You have to set up 3 separate equations. Y equals ax squared plus bx plus c. And then you have to reduce those equations down. Then you have to use substitution. Then you have to use elimination. Then you have to plug everything back in to solve for the last variable, and then you can write your equation. Okay? This one is where you can mess up the most because there are the most steps to do and because we got to pay attention to negatives and positives. Okay? I have no doubt that vertex form and intercept form you're going to do fine on. Okay? This is where people usually struggle. That's okay. Yes?
So in step 4, how did you get the negative 3 minus equals 2 minus 2 minus 4?
Because I took this equation here, negative 3a minus b plus c, and I just plugged a and c into it. So I said negative 3 equals 2 because that's what a was, negative b, and then minus 4 for c.
How did you get the second one? The negative 3 equals negative 2.
I added, I said 2 and negative 4 is negative 2.
Oh, shoot.
Does that make sense? I just combined like terms on one side.
So we're not graphing today.
You're not graphing today. You're just writing equations today.